Okay. All right. Well, let me pre-welcome everyone because we're going to have a few welcomers. My name's Allison Druin. I'm Associate Provost for Research and Strategic Partnerships, and I'm thrilled that our office has been able to continue this research tradition of having research talks from our own faculty, staff, students, and so on, really giving us a sense of what's going on campus. And because it's virtual, seems like we're getting a lot more people able to join us each month. So we really are thankful for all of you to be here. And we're also two people I'm very thankful for is Rebecca Pels-Friedman, who agreed to be our amazing, how would I say, sort of organizer, host, interviewer, that everything under the sun. She has been one of our research leaders over the last few years and is in the School of Design and really a force to be reckoned with when it comes to research in lots of different directions. And then, of course, Rachel Asher, who is our Associate Director for Research and Strategic Partnerships, who leads and organizes everything that makes these research talks happen. And in any case, I think I have now given enough time for people to show up. So with that, I'm going to pass it off to the people that are really running things. But again, thank you so much for you all being here. And we hope that not only do you enjoy today's speaker, who's going to be awesome, we know, but our spring semester is also going to have some other fabulous speakers as well. All right, passing off to Rebecca. Or
Hi,
do I?
everyone.
Yes, Rebecca. Okay.
Hi, everybody. Thanks so much for joining us, especially for today's research talk with Sarah Nunberg. So just to give you a little background, the mission of the Research and Strategic Partnerships Office is to foster new and exciting research opportunities for faculty, staff, and centers at Pratt, and to help make connections with each other, which is what I think one of the things that this talk series does really well. But we also want to make these connections with industry and community partners outside of the Institute. So one of the ways that we're doing this is by providing this platform for research active faculty to talk about their work and inspire you. I find it really inspiring because I meet a lot of people that I wouldn't necessarily meet on campus. One thing that you should note is that this presentation will be recorded. So, and then the recordings are going to be published on our YouTube channel. So if you find a talk interesting and you want to share it with someone, just direct them to the YouTube channel. So in addition to our conversation with Sarah today, I encourage you to check out the other recordings that we have of our previous talks on the website. And that website is prattresearch.org. We'll paste that into the chat for you. And to mark your calendars for our upcoming talks, they will run through May. So we're always, one other thing, just a plug, we're always looking for other presenters. So if you're interested in presenting your work, please let us know. We will also put the email for that into the chat so that we can reach out to you and talk to you about setting up a time for you to present. So today, we're excited to hear from Sarah Nunberg. Sarah is a relatively new member of the Pratt faculty, and she teaches a course in the Math and Science department in materials degradation, and has also taught in the art history department on tech and structure. I think it's so interesting that she teaches in both departments. And that course in the art history department, it was specifically around the ethics of conservation, which I had a really interesting conversation with Sarah yesterday about. And I'm really excited to see where the conversation goes today. So she has this diverse background, having studied undergrad at SUNY Albany and then transferred to Hampshire College to finish her bachelor's degree, followed by a master's degree in archaeology from Yale, where she focused on her area of expertise on Maya pottery. This led her to a Master's of Science at NYU in their Conservation Center in the Institute of Fine Arts and Conservation. She lives in Brooklyn with her husband, who's an architect, and has 2 college-age daughters. She's got a private practice in antiquities conservation. And as her career has progressed, she's become more and more interested in the sustainability of the materials used both in art conservation, restoration, and art creation. And her talk today is about the research that she's doing to create an open source tool for artists and art conservators to use to understand the sustainability of materials in their practice. So we're going to start with a presentation from Sarah, followed by a conversation. So please get your questions and comments ready for her. You can post them in the chat in real time, and then we can address them in the Q&A session, or you can just ask them. So I'm going to turn it over to Sarah, but first, like Rachel Maddow says, I hope I got all that right. If I messed anything up, please correct me. Sarah, turning it over to you.
Thank you. Can I share my screen? Okay.
Yes, you can.
Okay, here, I'm going to do that. I just have to. I don't usually use PowerPoint. I mean, and my talk, just give me 1 second. I have to put it in presentation mode. Sorry. Okay. All right, I first have to share it, sorry.
Oh, good, we can see it.
Okay, you can see it now? Great. So today I want to talk about a project that I've been involved in since starting in 2008, and then in an NEH grant, first in 2017, and then in recently in 2019, which I've brought into Pratt. Right now it's called STITCH, Sustainability Tools in Cultural Heritage Preservation. And it's very much a collaborative project. Myself, and then I'm working with Matthew Eckelman, who's an engineer at Northeastern University. His PhD student, Sarah Sanchez, and Sarah Sutton, who she has a practice called Sustainable Museums, and she does a lot of work in looking at how cultural heritage work can can work with museums and institutions towards sustainable practices. We've also worked closely with Eric O'Toole at Pratt in Communication Design Department. He's designing our website and all the materials for this project. I want to just step back and start with the big picture of the project I'm working on is really looking at how can cultural heritage sector, not only as a conservator, but also as preparators, architects. Well, architects are doing this very much on their own, but artists, registrars, exhibition designers, how can we start working with sustainable development goals in our minds and really working to start achieving those. These are the UN 17 Sustainable Development Goals. And as part of our project, we have looked at really how does our project fit into these sustainable development goals? And there are about 8 of them which we do fit into. So this project is really looking at life cycle assessment for cultural heritage. And the reason why I started becoming interested in this is, as a conservator, I work with a lot of materials that also artists work with. And as I was working with these materials, I would always question, first of all, what are these materials doing to my health, and what are they doing to the environment? When we are creating all the waste that you can see if you're facing your slide on the left, you know, when we're working, we're using cotton swabs, we're using syringes, we're using sterile equipment that's used in the medical field. Do we have to be using sterile equipment? How much energy goes into sterilizing a scalpel? We use scalpels all the time. Like I said, syringes, disposing of this material. Our work is very important and very specified. We are required, we do a lot of chemistry, but do we need to then lose sight of the big picture, going back to those sustainable development goals? At this point, our field is advanced enough that we need to remember what we've learned in getting as far as we've gotten in setting parameters for environmental management, understanding materials, how the environment interacts with materials, understanding materials that we're injecting into cultural heritage. The slide in the middle with the glove, I'm working on a Louise Nevelson sculpture. I don't only work on ancient art, though that was my beginning real goal and love. But as a private conservator, I've had the opportunity to work on a whole range of materials. And one was working on a Louise Nevelson sculpture. And I'm injecting an adhesive phenori made out of, it's actually out of seaweed, into paint to set it down. And actually another choice I could have used was something called isinglass, which is made of sturgeon glue. And I was working with a paintings conservator who said, we need to use sturgeon glue. And I said, I'm not using sturgeon glue because sturgeon is an endangered species. How can I justify using that? But now I'm finding through some of our research that phenori, farming phenori can be quite damaging as well. So that's something called burden shifting. So the long story, to make the story a little shorter, in conservation, in my work, I started questioning all of this, and I have been questioning that. And I started learning about life cycle assessment back in 2008. And I know that at Pratt, there is a lot of work with life cycle assessment. And I started looking for a practitioner in LCA, an engineer who could work with me, who could start helping me use LCA and who could help me introduce it to my field, because still most people in my field don't know about it. So we started doing research and doing some LCA case studies, mostly at the MFA in Boston with another conservator on some situations at the MFA. And we began to introduce it into the museum field. So after doing about 8 case studies with Matt Eckelman, who's the engineer from NEU, Northeastern University, we realized that really a lot of products in cultural heritage that we use are not in the LCA database. And a lot of the questions that we were asking, such as environmental management, where conservators have set very strict parameters of 50% relative humidity at 70 degrees Celsius, at 70 degrees Fahrenheit, are really pulling a lot of energy restrictions and requiring a lot of energy, but really how much is it? Can we evaluate one situation? And we realized that we need to do this situation by situation. So we came up with the idea that we could create a library of case studies looking at situations, and we could create a tool of materials specific for cultural heritage. Now, again, when I'm saying cultural heritage, I'm not just talking about conservation. I'm talking about artists. We're creating a tool and a library, but populating this tool and library are a whole range of paints. we're looking at paints made by Golden Paint, by Liquitex, all different types of paints, fabrics, canvases, supports for canvases. So all of these materials are going to be valuable not just for conservators. So to step back, we applied for and received a grant in 2019 from NEH, a $350,000 grant, where we are creating a tool and a library of case studies. It's through the Foundation for the American Institute for Cultural Heritage, for Conservation of Cultural Heritage. We changed our name, and it's always confusing. But we applied through that foundation. And the grant we applied for is multifaceted. It's to create the tool, create the library of case studies. The tool right now has about 2,000, is populated with about 2,000 materials. The library will have about 15 case studies. Also an information page, and also an exhibit of the case studies and of what we're doing. Eric O'Toole and his students at the Communication Design Department at Pratt will design the exhibit. It will be exhibited at Pratt, and then it will travel to other institutions that are involved in our work. We have been working with graduate students in conservation. There are 4 graduate programs for conservation in the States, and we're working with professionals from those graduate programs, and students from those graduate programs worked with us over the summer to populate the tool and to come up with case studies. So that's what we're working on now, and that's what we're presenting now. So the tool will be the kind of thing where you can plug into the tool. I'm looking at, if I use one liter of acetone versus 1 liter of ethanol, which has the worst impact? And it will tell you the kilograms of the carbon, the CO2 equivalent of that material, and you can compare it. It will be a bar graph. We will also have the links to the safety data sheets, because it's more difficult with the tool to do human health impact. So this tool and library will live on the FAIC website, and Eric O'Toole and his students are designing the website and the interface. So it will be beautiful Pratt design, which is very exciting to me. We are halfway through our first year. We're halfway through the grant. We've done our first year, and we will have the second year completed. Okay. So just very briefly, what is life cycle assessment? I know a lot of people here probably already know what it is, but just to tell you in case people don't, life cycle assessment is a quantitative modeling tool for quantifying the system-wide resource inputs and environmental emissions and impacts of a product or a service. So it's a very good way to compare something. I don't know why it's not happy to. So let's think about a newspaper. What goes into making a newspaper? Using it and distributing it. First, we think of manufacturing the newspaper. What materials go into manufacturing it? How far back are you looking at the systems boundaries of this? The material production. You can think all the way upstream to the factory that is going to be logging the logs to make the paper. You can think of manufacturing it and then using it and distributing it, and then recycling or disposing it. So the life cycle of a newspaper emissions can happen far away, and it can happen right at in your city. The environmental, I have to move my screen. The environmental impacts can occur at each stage of the life cycle and can be intuitive. And you need to consider all stages in order to form design or policy decisions. And that's what we're talking about in the tool and library that we're creating, is that people can assess each stage of what we're doing to make new decisions, to start thinking outside the box. We've had to set, as conservators, we've had to set certain standards, and and people who are choosing materials, we set certain standards. But now let's start thinking farther than that. Let's start reconsidering what our choices are so that we can make better choices and start changing how we're thinking and the choices we're making, so that we're thinking about the world we're living in. We're not just thinking about under our microscope or just at our desk or just this one thing that we're making. And we're looking at multiple environmental impacts, not just the water impact, not just the air impact, but we have to consider all the impacts, so that we're not just shifting the burden from one impact to another, so that we're not just cleaning up the water and then polluting the air. So it's about measuring sustainability, and we can look at cost, but we're also looking at the social and environmental impact as well. So you can think of all the aspects that are, all of the materials that are going into making something like this crate. You have the wood, you have the metal, you have the ethafoam, and so this crate's going to be used to ship art. So everything's interconnected, but the problem with LCA is you can start going down so many rabbit holes. That's where you need to start working on your systems thinking. And this is something, as a conservator, I never thought about. And I started reading about systems thinking, and it has really affected the way that I design my treatments. And really, you can start doing it with everything you do when you start thinking, okay, how far out am I going? How far down a rabbit hole am I going? Am I only looking at, if I look at acetone, am I only looking at the impact of it here in my studio as I'm using it? Or am I going to start looking at, producing it all the way upstream to then disposing it downstream? Am I going to start looking at the cotton swab that I'm using? So you can start including everything, but to do a study, you have to start outlining these studies to make them impactful. When you do a life cycle assessment, you have to do life cycle inventory, and this is what the database looks like. How do you actually do an LCA? You set the goal and scope of the study. You look at the materials, manufacturing, assembly, and always transportation. Transportation really has high impact. You can look at linked industrial processes, economic models. Then you assemble it into a life cycle inventory, and then you do your assessment with emissions, fate, impact. And then interpretation is very important. And then there are the standards set by the ISO. I don't want to go into this too much because I know a lot of people know about this. And if there are questions, we can talk about them later. This is the beginning of our website. It's the very rudimentary design. Eric O'Toole and I are working on this. He's revising it as we speak. There's a mistake here where it says ultraviolet analysis. This is not ultraviolet analysis of this object, but this is the beginning of the website. It's going to live on the FAIC and the AIC website. It's free, accessible to everybody. Anybody can use this, which is an awesome part of what we're doing. This is the front page. You will be able to look at the tool, access the tool, our case studies. We're going to have information sheets, like what does it mean? If you're looking at water, what is our impact on water? What does it mean when something is environmentally friendly? What does greenwashing mean? So we'll have different information sheets, and we'll have a search tool. Then we're going to have our case studies page. Here's our table of contents, and these are the types of case studies that we're developing. Some fall under treatment, where we're comparing consolidants. So that will be like different resins, different resins made of acrylics, different resins made of animal and plants. That's where the isinglass, the sturgeon glue, and the phenori, the seaweed adhesives that I was talking about earlier, that's where those fall under. Rigid gels, we use a lot of gels for cleaning, dry cleaning materials for basketry. We're doing a lot of environmental energy examinations. One is a lot of photograph collections. Those are preserved best in cold storage. So we're looking at cold storage, the energy involved, the materials, the refrigerants involved, the actual freezers themselves, the energy for that. So that's, and then building, we're looking at historic building window assemblies. We've looked at the entire assembly of glass from the storm window to films that go over the windows to plexi. And we have found so far that of the entire window assembly, which is really interesting, the highest impact is from the aluminum frame of the storm glass, not the plexi, not the film that can be a UV blocker. So that's been a very interesting study. We're also looking at materials. This is where artists, a lot of artists' work will come in. We're looking at linings for paintings, so those kinds of fabric linings, also adhesives that are used, looking at backing boards, so that's looking at foam core, coroplast, different types of heritage board and cardboard, so it's really interesting comparing archival boards and boards made of plastics versus just plain old cardboard. What is that environmental impact? And gloves. Everybody always wants to know, what is that impact of all the nitrile gloves that I'm using and throwing out? And then we're looking at crates, packing, and I'm going to talk about that a little bit. So this is what a case study is going to look like. One of these case study pages, Eric designed this. He's going to work a little bit more on the gloves pictures. But this, and so on one of our case study pages, this is going to live in our library of case studies. It will have the project designer's name. Usually many of these project designers are students who worked with us over the summer. And then the background of the material, and then some references, and then the goal and scope of the project. And this is just the beginning of it. And then as our work gets developed, we'll have the results, we'll have graphs and recommendations. So this page is going to grow. This is just the beginning. So this is one example of one of the case studies that we've almost completed. We've looked at one of the projects is looking at a crate. What goes into, what are all the parts of a crate, and what are the environmental impacts? So we're looking at the crate we're comparing each part of the crate and looking at them by degrees of impact. So we divided it up into 3 parts. We looked at the crate outside, the shell made of either wood or fiberglass with a resin, and then the vibration absorption, which will be a foam, and then something that you wrap the art with, which will be LDPE or Tyvek or a tissue. And so in doing an LCA of all of these materials, then we can look at what are the hot spots, what are the least sustainable materials, and then can we find alternatives, more sustainable alternatives. So the scope of the study is looking at the materials from cradle to gate. Eventually we will do cradle to grave. We have 4 different scenarios: a single use, so one that just goes, say, from Pratt to the museum; one that is standard, so it goes back and forth; a museum higher grade, so that's going to be everything inside the crate will have more environmental buffers, so that's going to have more foam; and then a reusable crate. So in looking at these different scenarios, we can start seeing real differences in the environmental impact. The single-use crate, ironically, has the lowest impact, and I'll talk about why. And then the standard and museum has the higher impact. The reusable crate, even though it's made of a lot more products that you would think are less environmental impact, higher impacts, like the outside is fiberglass with a resin, and the outside of the other crates are wood. It's reused so many times that it's going to have less impact. So then we're looking at the inside of the crates. Oh no, this is looking at transportation. So transportation of these crates by truck, you start looking at the weight of the crates and how many times they're going, and you start seeing that the reusable crate has its impact goes up because it's a heavier crate in itself. So then when you start breaking it down by parts of the crate, the highest impact aspect of the standard and the museum crate, we're not including the reusable crate because it's made of different materials, is the foam. So that gives us something to work with. So what products can we replace the foam with? So then we start looking at new products that are available to us. And we'll really start looking at, well, what is the goal of a crate? It's to carry an object, a fine art, breakable cultural heritage object from one spot to another. Now, if we're looking at something that's made of metal that's going to be highly reactive, and you're really going to need to make sure that it's not going to react with the packaging material, that it's that even if it's just being transported for 72 hours, then you may not consider these materials. But there are a lot of materials like ceramic, stone, so many materials that are not so reactive, that can be put in maybe less pure, less processed materials that are going to have a much lower impact environmentally, especially if you're just using it for 72 hours. So if you think back on the slide of how high an impact that polyurethane foam has on the environment, and if you're thinking that you're just using it for 72 hours and then throwing it out, is there something else we can replace it with? So just an initial look was at the mycelium foam, which is an amazing product which can be grown around a shape. So you can CNC mill a shape of an object. So you can scan an ancient object without touching it, scan its shape, and then grow the foam around it, and then use that as packaging. Can we replace the shell, the wooden shell of a crate? Maybe we can start using FSC wood, or wood that's made from, of course, with non-formaldehyde, urethane, adhesives, soy-based glues, but maybe instead of particle board, maybe we can use wood that's made from like wheat or rice. So there are a lot of different kind of wood products out there that are viewed as more sustainable. So we need to start doing LCAs of that, and also do research on other products. This is just the beginning of searching for some products. One other example of a LCA that we did was looking at a Spanish Romanesque arch at the MFA in Boston. It was consolidated with something called silanes that conservators use. That's mostly used for outdoor material, but because this is sandstone, silane really is compatible with sandstone. And then comparing it with an adhesive that conservators use a lot, which is an acrylic resin, a methyl methacrylate called B72. And each was put in xylene and in acetone and in ethanol. So it's not only looking at the consolidant, but also at the solvents. And solvents are something that not only conservators are concerned about, but a lot of other artists. And so we were looking at this, and you can see at the bottom of the slide, we're comparing ethanol, xylene, and acetone. And here you can see, this graph is a little bit blurry, but in terms of global warming and the CO2 equivalent, you can start seeing the resin. This is the B72 resin, and here's the silane resin. So the silane resin has a much higher CO2 impact. And then if you're looking at ethanol and acetone, that the xylene is much higher, but ethanol and acetone is much higher than just acetone. And then of course, transportation always has an impact. Human health, cancer, again, the silane is much higher. And then you can start also looking at the human health impact of acetone, ethanol, xylene, and ethanol. For conservators, this is very scary because we use ethanol and acetone all the time. Xylene, we've really stopped using. But there's still quite a bit of impact. And so it really makes you start wondering, at what cost are we doing this? At what cost to the environment, and at what cost to the objects, and at what cost to our health are we doing our work? And we really need to step back and look at this and start weighing out, once we know this information, once we are educated, how can we keep working in the way that we're working? Oops. So our next steps are, we're launching the website's not complete in the design. Hopefully Eric's going to have, we're working with the design and with building the website. That's going on in the next 2 weeks. So we're hopefully launching at the end of this month. We have about 10 more LCAs to complete for the case studies. These are some of the LCAs that we're working on. And then we will also have, we have the database, the spreadsheet of all the materials included in the tool, but we will be modeling all of the materials in the tool and having the tool up and running. So that's the work that we have to do over this coming year, and our exhibition and that design. These are all the people who have been involved in this work. It's been an unbelievable learning project for me. Another next step for me is creating a curriculum to teach this tool to people who are very hands-on oriented in their work. And I think that's going to be a tremendous challenge, so that this tool doesn't just sit on the website and not be used. It's a great encouragement, I think, for people who always say, there's nothing I can do. You know I'm using these materials and there's nothing I can do. But this puts it in our hands independently, individually, and it gives us the power to do something. And the tool is going to be so simple to use that literally all you do is open it, put in a number, find your material, and compare it. So yeah, that's my project. Thank you for the opportunity to share this with all of you.
Thank you very much, Sarah. That was great. And I wanted to open it up to questions, to anybody in the audience that has questions about the project, and probably they have questions for you about your tool.
Yeah. Chris?
Hi, Sarah. Thank you so much for this. This is very exciting. Just to give other people context, when I'm not acting like a chairperson, my usual job is to teach ecology and evolution courses, and we do in our environmental science ecology courses a little sort of primer on LCA. So I'm very interested in this, and particularly, like, often at times the students' experience is like, well, I'm a fine artist. I'm just going to be making these few little sort of precious objects that are not, I mean, compared to my friend over here who's in industrial design, who's going to design like one thing and it's going to blow up because it's going to be like 10,000 units made or something like that. So I'm kind of curious if you've encountered that attitude, which is that, like, well, for fine arts, this doesn't matter because the volume of these things is very small. And how do you maybe, I mean, I think your work itself is already countering that attitude, but how do you deal with that kind of attitude?
Yeah, I've disappointingly had colleagues and mentors in amazing museums that are natural history museums, say, well, our work is so little, we use these teeny vials of acetone, whereas industry is using gigantic vaults of gigantic things of acetone. So it really doesn't matter what we do. But then you look at I have a slide that I didn't include of how many museums there are, how many people work in museums, how many conservation projects there are going on, how many exhibitions there are a year, how many objects travel a year, and you start multiplying all of that, we cannot work irresponsibly. It's just not. And also, what we do in cultural heritage institutions affects education. They're education institutions. So how can you, especially someplace like a natural history museum, where many natural history museums are putting up exhibitions of sustainability and climate change, and then not practice that themselves. And you can't isolate yourself. You just can't. We can't do that anymore. Not only can we not, but soon some of the materials that we rely on will not be available, or will be so expensive that we're going to have to start figuring out other things. Ethafoam should not be available. And I called Dow, then they transferred me to Seal Air, because I said to them, we're doing LCAs. We have found such high impact about ethafoam and eufoam. Do you have another product? Because we would like to do an LCA. And they said, oh, we'll get back to you. We're working on new packaging material. We'll get back to you. They never got back to me. But these things have to start changing. And mycelium foam, these websites, they're starting to make packaging material for IKEA and for Origins and different. If you go on their website, you see how much design they're doing. So they're going to start really making money and outliving it. So yeah, to all the artists, yeah, we all think that we can think we're living in a bubble, but we're not.
I also think the human health part for conservators is particularly an issue, right? Because maybe there's not so many conservators, but we don't want them all to be sick in current day or old age, right? Because of the things they're using. And so that's something where the unit of impact is a single human, and that's a very important point.
It's really disturbing because there's the way that our field still works is by word of mouth often, and there'll be a guru. There'll be like one person who who kind of knows too much about chemistry to be dangerous, but not enough to be doing it right. And everybody will turn to that person. And one example is I was working, the Nevelson project I was working on, I talked to him and because everybody said, you have to talk to him, you can't do this project. And we had already come up with a system of how to consolidate the paint and how to remove one layer of paint from another while preserving the bottom. And I talked to him and he said, well, you have to use these silicone solvents to first consolidate this top layer, because silicone solvents disappear. They sublime, they evaporate on their own, they just go away. And silicone solvents are in makeup, and they're in shampoos. So they're in shampoos at 0.1%. And he's recommending using it at 30%. So they're using it in vats. I mean, literally vats of it open at 30%. It's called D4, cyclomethicone D4. And it's toxic. It's toxic to it's like works on your ovaries. I'm sorry, I'm blanking, but and in rats they found, it has like LD50, and it's just a horrible product. And there are young women conservators who are getting pregnant working with this material, brushing it on large surfaces, because this guy who's the guru says you can use it. And now in Europe, they're banning the product. So you can't find it in your makeup anymore, but here slowly it's getting phased out slowly. So look at your sunblock, or at your shampoo, or at your skin cream. It all has dimethicone. If it has dimethicone, don't buy it. Buy the product that doesn't have it, because then that product will be made and we'll have access to it more, because it is a toxin. So Chris, yes, conservators, health. I mean, there are just so many stories where you just listen and you just go, what are you doing? This isn't an old boys network anymore. We have to take care of ourselves and the planet. And then people will say, well, so what if it affects marine life? I'm fine with it. So I'm going to buy a whole bunch of the dimethicone before it goes off the market. Anyways, I can go off on it.
Well, it sounds like the tool would be like a very useful thing for a more junior member of a conservation team to be able to like at least turn to and say like, hey, here's the things we're using, and I can actually, I've been having these misgivings or feelings they might be dangerous, but here's actually like a quantification of the danger that we're putting ourselves in.
Yeah, and to make educated decisions.
So Sarah, you have a question in the chat from Antoinette. Antoinette, are you on? Do you want to read your question?
Yes, hi. Can you hear me?
Yeah.
Yeah, hi there. I'm listening here from Dublin, Ireland. I work for an art handling company here, and actually just during lockdown, I'm so happy I've joined this talk, Sarah, because I'm trying to look at materials and recycling and looking at sustainability. We use a lot of PE foam for our crates, and sometimes plaster's out, but not so much because it's more expensive. And firstly, I was kind of wondering, is it recyclable? Now, obviously, things over in the States are, recycling is different, whatever country you're in. But I just wondered, did you have any information on that? Well, firstly, do you know, are you familiar with PE foam? What does that stand?
Polyethylene foam?
Yes.
Polyurethane?
Yeah. Polyethylene. I think I've written it up here.
That's white and it's has a
Yes.
specific density. Yeah, that's one of the products that we examined.
Okay.
And as far as I know, it's not recyclable.
Oh, typical. Yeah. Okay.
So I would reuse it as many times as you can.
Yes. Yeah. I mean, what happens is we're transporting a lot of artworks, across the world, and the crate is, we say goodbye and the crate is gone.
Exactly.
And no doubt a lot of times those crates are just disposed of.
Yeah, they're used once usually, right?
Yeah. And also even with the foam, it's glued on with a glue gun. So
right.
It's hard to, it's just, it's all this time consuming stuff, and, and then the look of it and the optics, and, it's fine art and it has to look good, etc. Is there any other foams that you would be aware of that would be a better? I know you mentioned something about a kind of a foam that wraps around objects. So that sounds kind of expensive.
I don't know how expensive the mycelium foam is.
Okay.
Mycelium, it's made from mushrooms.
Wow. Okay.
They grow it. I can send you a link. There's a couple of companies here in the States. I think it's in Vermont. I don't know how expensive it is. I've been searching for another product. Again, yeah. I called Sealed Air that makes the polyethylene foam, and they don't have another one that they're working on. But part of my project in this, and I don't know if it's going to turn into another grant or what, is we would like to, now that we do the LCA, then find other materials, like to do I would like us to do an LCA on the mycelium foam, compare it. We didn't. Do you know what an Audi test is?
No, actually, no.
Oh, it's a accelerated aging test on materials to see how they interact. And so one was, I had someone at the Metropolitan Museum of Art in Manhattan do it, and on the mycelium foam, and it didn't pass, which means that it off gases too much, so that it causes corrosion products on metal. So it's looking at copper, silver, and lead tabs, and what kind of corrosion products it creates when it's put in a chamber with a little bit of humidification over at 60 degrees Celsius for 30 days. But I really think that we need to start changing those standards, because what are you shipping? If you're shipping, like I said, okay, if you're shipping an ancient metal object, yes, you're going to need to use probably your polyethylene foam.
Yeah.
But if you're shipping something like a ceramic vessel that is highly stable, or
Exactly.
if you're shipping, you know, a textile, you know, we saw that the LDPE wrapping that we did, like very fine plastic wrap, we did the LCA on it, and that had a very low, had like the lowest impact of everything in the crate. So
Yeah.
let's wrap the mycelium foam in that.
Yes,
Create a
yeah.
barrier between the mycelium foam and the object. It's better to do that than wrap the object in it, because you can have condensation occur and everything. You could wrap the object in tissue, which is what I always do anyways. So wrap
Yeah.
the object in tissue, that's going to protect it. Wrap the foam in LDPE or something else. Let's think about what we can wrap that mycelium foam in.
Yeah.
Or let's find other products. You know, people are looking at wood shavings. O'Keeffe shipped her pieces in bales of hay. That was, and studies were done showing that bales of hay had incredible vibration absorption.
Okay, yeah.
So, you know, this is not brain surgery. We do not need a sterile environment for objects of art. And when we
Yes.
do, we know enough now to identify when we do. We know enough now to identify when we don't. We need to use that knowledge, not to just have a recipe across the board without thinking. We have
Of
enough
course.
knowledge now.
Yes, yeah, yeah.
So,
And I suppose working in the art industry, there's so much waste. You know, so much waste. We use a lot of poly, we use a lot of bubble wrap. Well, not so much bubble wrap anymore, but you know, and it's just constantly dumped. I get so ill.
yeah.
Working in this industry for that reason.
I had
hard choices.
one general question that I don't think was brought up at all. And being an industrial designer, I have to say that I'm wondering about cost. Like, sometimes cost is a driver for your decision making. So is there an element to your tool that's going to show, like, actually it's cheaper if you use these better materials?
No, there is something called life cycle costing, and we have done life cycle costing on looking at LED lamps. When you do life cycle costing, you know, often you want to do it comparing energy analyses. Maybe, you know, we could do some life cycle costing when it comes into the case studies. You know, in doing our historic window examination, you know, if you're choosing one over the other, what kind of energy savings are you finding? Doing life cycle costing for this tool is beyond what we're doing. Maybe when we expand it, we could, but that's also something you're going to always have to change in terms of how much money something costs and where you're buying it. So that's kind of hard, but it is a good question.
Okay, well, thank you. We have a few more minutes. Do we have a last question that anybody would like to ask? I'm sure I'm going to volunteer you, Sarah. I'm sure that if people are interested, they could reach out to you. Would that be all right?
Anytime, yeah. And someone mentions turtle box. Yeah, we looked at turtle box. We've done some work with that, so that's interesting too.
Any other last questions from the group? Okay. All right. Well, this has been a really fascinating talk, and I think you've gotten a lot of interaction from the audience. I like that we have such an international audience. Welcome to non-Pratt people to our talk. Thank you very much for attending. And until we can meet next month for the next one, I hope to see you guys all there. Thank you very much. And thank you very much for sharing your work with us, Sarah.
Thank you.
Bye, everybody.
Bye.